Hello everyone. Today I will be reviewing the history of anti-gravity research brought to you by Amy Eskridge in her recent presentation. I'll tell you who she was in case you don't know. Yeah, here is the presentation. Historical perspective on anti-gravity technology. I think it's a kind of maybe nice summary. So yeah, she was like an independent researcher, an entrepreneur, how she described herself here, co-founder of this company. Yeah, why do we know about her? It's mostly because she was one of these 10 or 11 scientists who died under unusual circumstances. Yeah. Recently. In this case, it happened in 2021. Yeah, on 11 of June 2022, Amy Eskridge, a prominent figure in Huntsville scientific community, known for her work in anti-gravity and experimental propulsion, was found dead at her home in Alabama. The investigators initially ruled the death of the Institute of Exotic Science co-founder as a self-inflicted gunshot wound, burgeoning federal investigation into a string of missing and deceased US scientists has thrust the case back into the global spotlight. Doubts regarding the official narrative have deepened as a collection of videos and texts detailing stalking, harassment, and death threats experienced by Eskridge has surfaced. Yeah, even up to kidnapping attempt. Yeah, but that's according to her own description. So we don't know whether it's true or was she just kind of paranoidal. Then she also claimed she was attacked by some directed energy weapon. Shows her burned hands as an evidence. Yeah, I see. Yeah, she claims she had daily death threats due to her independently developed theory, which tipped me over onto some kill list. The most striking messages, however, came just a month before her death. On 13 May 2022, Eskridge warned Milburn, "If you see any reports that killed myself, I most definitely did not." With these accounts emerging, doubts about Eskridge's death have deepened. However, her father, Richard Eskridge, a retired NASA engineer, has said he does not believe her death was suspicious. Well, it's kind of funny. Usually, when the media cover it, they say something like, he feels upset that the tragic death of his daughter became a source of all sorts of ridiculous conspiracy theories. Just like, no, doesn't care. Just like, she was kind of crazy, crazy paranoidal bitch. Expected. It was totally expected. I don't know. Yeah, and I don't know what exactly happened. So yeah, I became interested in well, in this topic. I wanted to learn what exactly she discovered. Is it made up? And the thing is, I actually don't know. I don't know where to find this. Maybe I just don't know how to do it correctly. I'm kind of handicapped in using Google. And if I ask like AIs, it finds me instead just her presentation on the history of what's called anti-gravity research. And this presentation is what I'm showing to you right now. So I don't know. I assume she was doing similar thing. So instead, I decided to just make a review of what she included here. But I don't know whether it's similar to her research or not. There's the people who they have on the team. So first of all, there's some introduction here. Fundamental physical gravity is fundamental physical force. Yeah, she says that is 10 to 39 times the strength of front force. I mean, maybe she meant like 10 to the power minus 39. Yeah, it's just kind of it should be a power, I guess. It's not just, yeah, it's not 10 times not 10 39, 10 to the power minus 39. Yeah, so I think now it's kind of correct. So anti-gravity defines reducing, canceling, protecting against the effect of gravity. Okay. Seems fine definition for me. I don't know whether it's possible, but there are many people who try to do this. This is the history of gravity. Yeah, okay, that's gravity research. That's kind of clear. Yeah, so anti-gravity will require negative mass, and we don't have something like this. Unified field theory. So graviton was proposed, that the graviton was never found. Okay, so gravity research, anti-gravity research, the early days. So Brown's gravitator, Thomas Townsend Brown. Yeah, I already covered it in the previous video. We talked about it. Nikola Tesla space drive, 1929. Yeah, I think if I look at this patent, it's not really a space drive. Look, this is a patent which indeed belonged to Nikola Tesla, literally. But it's a patent of a helicopter plane. Look, you could check for yourself. The application is a continuation part of my application from September. The invention consists of a new type of flying machine designated helicopter plane, which may be raised and lowered vertically and driven horizontally by the same propelling devices, and comprises a prime mover proof design and an air screw. Both especially adapted for the purpose. Means for tilting the machine in the air, arrangements for controlling separation in any position, a novel landing gear, and other constructive details, all of which will be hereinafter fully described. So that's not like a flying saucer or anything. Look, it's just a simple, well, machine. Say pretty conventional. But I'm curious, I didn't know that Tesla did something like this. But it's very strange that your presentation should includes a picture of space drive. I don't understand. And the year, by the way, also matches, right? When 1927. January 3rd, 1928. Yes, so it depends on which she's talking about. But she's saying it's a UFO. I mean, the like a flying saucer or something. It's not. Yeah, anti-electromagnetic propulsion system, electropulsation, dynamic theory of gravity, the exact notion of curved space-time. Well, that's definitely not in Tesla's patent, for sure. I don't know what. Maybe there's this book which she's talking about, but then this book is full of shit. I don't know. Okay, Gravity Research Foundation. Yeah, I heard about this. 5 later Nobel Prize winners. Yeah, I don't know exactly what they were doing there. Yeah. So yeah, I think I'll look into it separately, because there's many people, yeah, and different type of research. Yeah, that's a topic on its own, right? And yeah, yes, there was some story with the interaction with US government. Okay, so that's first concrete device. Searl generator. Right. I think it looks like electric motor or something. So yeah, as a Searl effect generator invented by John Searl in 1946, is a purported free energy device designed to produce electricity and at high speed lift anti-gravity. Use rotating magnetic roles on concentric rings. But it's literally, it's kind of like a motor.
In the 1960s, John Searle revealed a very intriguing device. It was built out of a combination of magnetics, copper rollers, and electromagnetic coils. He claimed that the electrons would gain velocity in a spiral pattern inside the magnetic field. With a certain RPM and phase offset, it was claimed to produce an excess amount of power. Naturally, many followers attempted to replicate the device and its effects. One of the biggest replication projects stemmed from Washington and Godwin, and they claimed to see a 7% reduction in weight as well. But the claim has yet to be verified, and there could have been offset vibrations in the machine that could have resulted in misinterpretations and weight change. The excess energy output also violates the first and second law of thermodynamics. Does the machine produce an anomalous effect, or is it just simply an overcomplicated motor? Well, let me know in the comments.
Yeah, I don't know. Nothing seems out of the ordinary here. At least kind of naively. I don't know why he was thinking it produces some sort of anti-gravity. Okay. Dean drive. Well, also interesting mechanical device. I looked at it. We need to find, I think we need to find patent for it. That's the right way to go. And the patent will explain how it works. So it has this two gears connected to a motor here, and each gear is connected to its asymmetric weight. And this asymmetric weight, well, they're connected to the systems of springs. So I don't know exactly what it's doing, but it's kind of when you rotate the motor, these things will well also make these revelations, right? Like this revolve around the axis and make these things kind of jump or something. I don't know, but it's not really an anti-gravity in any sense. I think what's gonna happen, it will be like jumping like this a little bit. Maybe like mostly like vibrating and making noises. I don't know. It's not gonna fly in the air or anything like this. Again, he claimed it violates Newton's third law of motion. But people didn't really confirm it. Dean, who was trying to find potential buyers for his technology, was secretive about the details of how it was supposed to work. As standard problems. And then it was hard to reproduce, and then, nobody believes in it. And like, yeah, why should it produce anti-gravity? Yeah, it doesn't. It's just like no system of gears and springs. So that's kind of weird. Let's move on. The Wallace machine. Okay. Also, Henry Wallace filed several patents related to what he termed a kinematic force field, which claimed to generate non-electromagnetic force fields through the dynamic interaction of rotating spin nuclear materials. This patent describes a method of creating a secondary time-varying gravitational field by rotating materials with high nuclear spin, such as copper, zinc, or lead, in a manner that creates an undulation of the dynamic interaction field. Okay, here is the patent. Yeah, and it seems like, so the key component is this part, which has, well, just a rotating disk inside, made of this special material, which is what Gemini suggests us. The core idea involves utilizing the interaction of the angular momentum of atomic nuclei in moving bodies to couple with gravitational fields. I'm aiming to create a kinematic effect. The devices involved counter-rotating disks of specific materials to create the claimed force fields. Well, yeah, but I don't understand. It's not like gravity couples somehow directly to this, to nucleus. I mean, they interact with gravity just like any other particle, so very weakly. So yeah, I don't know. Again, I see no reason why it should work. Well, it seems like the idea, the design at least is simple. So I assume he should have tried, and what? I don't see any even reports about whether it works or not. Okay. Well, let's move on. Laithwaite gyroscopes. So Eric Laithwaite, actually, yeah, she's read one of the inventors of the maglev. So he's like a famous engineer, but I don't understand what she means by this. If I try to Google it, the only thing I find is just a video demonstration of him giving a lecture. Wait. It's something like this. Oh, I don't have Instagram.
Wheel. It's of iron and weighs, we'll see in a minute, quite a lot of pounds. It's 13 inches diameter and it's mounted on a shaft 3 feet long. You'll see that it weighs about 40 pounds. Now what I'm going to do next is to spin it up to 2,500 revs a minute with some assistance. When it's spinning, it becomes a live thing. In a minute, I'm going to let go with my left hand, and holding with my right only on the far end of the shaft, I shall lift it 5 feet in 3 seconds, and I shall talk to you quietly as I do it, because it goes up all on its own, you see, without any real conscious effort from me, other than simply steering it round a path that I happen to know it likes to go. When spinning, that wheel has enough energy to throw itself 200 feet in the air. I can lift it with one hand, using virtually no force at all. You'll also notice that as it went round in a circle, there was no centrifugal force trying to pull me across the laboratory.
Well, yeah, but he was able to lift it by one hand even before it was spinning, right? So it's not like the weight is reduced. It's, well, it doesn't, yeah, I don't know. The people think for some reason that gyroscope, like they, like, I don't know, cancel gravity, but it's not the case. It's, well, you still have to do the same work to like lift the gyroscope from the ground. It's not, yeah, certainly, yeah, you could hold it like this in a way which just seemed unusual, because it seems like it doesn't tilt right when it should, because it's rotating, because it has a big angular momentum, like in horizontal direction, so it couldn't just fall down like this, but you still have to hold it. So I don't know. It's not like this guy was trying to claim that gyroscope cancel gravity or anything like that. It was just a demonstration from his lecture. That's all. He's a professor somewhere. So yes, if you check who he is, yeah, so it's true. Oh, sorry, we can't find. Eric Laithwaite, electrical engineer, father of maglev. So yeah, I don't understand what she was trying to say here. Let's move on to modern efforts. She's talking about Mansfield Amendment, restricted research by the DoD for non-military applications. Yeah, this actually happened, right? The amendment include many other things too. Yeah, reduce troop levels abroad. Restrict the Department of Defense funding to research projects with a direct apparent relationship to specific military functions impacting university research. No, she's probably trying to balance the budget. Expressly limited Advanced Research Projects Agency funding to projects with direct military applications, which shifted research towards the private sector. Well, yeah, so he was basically a good guy. Okay. Hutchison Effect. The collection Hutchison Effect is a collection of enigmatic, often contradictory phenomena observed by Canadian inventor John Hutchison starting in 1979. It reportedly involves accidental, highly complex electromagnetic interference, creating effects such as material levitation, metal fracturing, melting, and jelly-like metal states without external heat. Discovered accidentally by John Hutchison in Vancouver in 1979 while working with high voltage equipment. Yeah, that's already read. The effects were produced in clouded laboratory settings using a combination of radio wave sources, Tesla coils, and Van der Graaf generators. Scientific reception. While Hutchison demonstrated the effect for some media and researchers, it was largely dismissed by the mainstream community due to the inability of independent research to consistently replicate the results under controlled conditions. So how it looked like, well, I don't know, we could watch this. I think I watched this video before.
At the fringes of science and mystery lies a peculiar claim that refuses to disappear, the Hutchison Effect. Named after Canadian experimenter John Hutchison, this phenomenon supposedly involves a collection of bizarre and physics-defying effects. Objects levitating, metals fusing without heat, and materials turning into a kind of jelly. These effects, Hutchison claimed, were achieved using a strange combination of electromagnetic fields, radio frequencies, Tesla coils, and static. So let's ask, could this be real science?
So maybe there's a video of how it looks like.
The remarkable works of Canadian inventor John Hutchison has drawn widespread attention from businessmen and government scientists since 1979, when he began using ultra-high electromagnetic frequencies to transform matter in some very unusual ways. It has come to be known as the Hutchison Effect.
The objects here.
Yeah, but the problem is this kind of could be faked. Yeah, these videos. So I don't know. Yeah, it would be better if somebody would recreated it independently. Well, somebody said he replicated it.
Hi, So I was asked to look into the Hutchison Effect. Now, the Hutchison Effect is a group of mysterious effects that include things like metal exploding, melting different materials one onto the other, anti-gravity and levitation. And there's a whole load of Hutchison videos out there, especially some that he took himself of his experiments that I've been able to have a look at.
Yeah, how do you know it's on a string?
When having a look at these things, of course, what it was all about was extremely high voltages in resonance. And to get a high voltage, of course, we have a high voltage supply. What we did was we made this for fractal burning, and it outputs a few thousand volts, and we can step that up to be a great number of volts. But equally, of course, what do we do with it? How do we get that to resonate? And then I remembered a friend of mine had sent me a couple of Tesla bifilar coils. So I've set those two coils opposite each other so that we can step that voltage up again and we can resonate it between the two coils, so we get a longitudinal resonant field right here created by extremely high voltage. Now, in theory, that should be able to set up an anti-gravity field, or at least that's what they're saying. And I've got here a child's toy. It's just a ball, it's a plastic ball. And I'm going to put it in the middle of the field and then turn that field on and see what happens to the ball. Because I'm going to remove any metal. We have the circuit here, and at the end of this demonstration I'm going to show you exactly how I did it. But anyway, let's have a look at that. I'll give you a close-up of the experiment. Well, that's amazing. Truly amazing.
Jeez, what?
Let's try that again. How about that? So in case you're in any doubt about how that was done, let me reveal the secret. There it is. And if you think that's cheating, let me show you another one of John Hutchison's films that he took of his own experiment and paid particular attention to the top left-hand corner.
So basically saying it's cheating. Well, yeah. So the guy's basically
Now, in
fraud.
case you think I didn't do a replication of John Hutchison's experiment, actually I did exactly what he did. I talked about high voltage, I talked a little bit about resonance, I chucked in a reference or two to Tesla and some of his marvellous inventions, and then I tied a bit of string to this and stepped out of the way and gave it a tug. That is exactly how that video was done. And you can even see the string waggling around in that top left-hand corner. I did a couple of other things. I mean, like John, I put a pulley in the roof there so that I could pull it as I was pretending to step out of the way so you could see it. I also did some setup before. I put this here because it's a black background, and I left it there as I walked out so that you were sort of aware of it and weren't thinking, oh, he's deliberately put a black background there. So I put a black background there, talked and stepped out of the way to give you a chance to see it, and of course that hid the string. And the string, I even left it there as a clue to how it was that I was doing this, so that string was sitting right on the bench all of the time, because it's often about misdirection. And there was a bit of misdirection and a bit of film trickery. I also layered up the sound in 3 to 4 layers to give it a realistic sound effect. All I did was turn that on and record the hum. It was never actually on while I was tugging this, so that it seemed that it was on and doing something. I want to give a quick header to this video, because it's never my intention to insult or upset anybody. In my opinion, the people who research into the fringes of science and things that we don't properly understand fall into two camps. There are charlatans who are trying to get you money, and there are genuine people who are looking for hope for humanity. And I have nothing but respect for those people, and I despise the charlatan. Now, my intent is never meant to undermine people's beliefs, to question what they think, or to ridicule anybody. I'm attempting to show that sometimes there are charlatans out there and how those charlatans might be doing their particular tricks. So with that in mind, if I am upsetting anybody, please do accept my deepest apology. It's not the intent. Let's get on with the main video. So a bit of a disappointment for me, for sure. But we keep on looking and we keep on hoping, don't we? Anyway, I hope you enjoyed the video. I hope it didn't upset too many people. Thank you very much for watching, and please do remember to like and subscribe.
Okay, so basically you kind of debunked it. Well, but of course this thing with metal, and it's where Hutchison even found these things. It's kind of hard to even fake it. Okay, but I don't really believe this guy anymore. Yeah. Okay, next. Reactionless thruster. Woodward effect. Well, okay, James Woodward was an American physicist who was professor emeritus of history and adjunct professor of physics at California State University, Fullerton. He's best known for a physics hypothesis that he proposed in 1990s, later expanded, that predicts several physical effects that he refers to as Mach effects. Woodward claimed the effect could be used as a reactionless drive for space travel. Okay, so is it? Yes, that's the paper. Well, it's kind of long. I mean, it's okay, not that long, 10 pages. Let's read the Wikipedia review better. Woodward claimed that his hypothesis predicts physical forces he calls Mach's effect, but are also referred to as the Woodward effect. He said that his hypothesis was based on Mach's principle that posits inertia, resistance to mass to acceleration, is a result of the mutual gravitational attraction of all matter in the universe. Thus, even mass of a given object can be varied while being oscillated in a linear orbital path, such that the mass is high when the mass is high while the mass is moving in one direction and low while moving back. Then the net effect should be acceleration in one direction. The inertial drag of the universe upon the object varies as its mass varies. Well, but isn't momentum still conserved here? I mean, it should be conserved. Why? How would it work? Yeah, the effect is controversial because within mainstream physics, the underlying model proposed for it appears to be faulty, resulting in violations of energy conservation as well as momentum conservation. Woodward and his associates have claimed since the 1990s to have successfully measured forces at levels great enough of particle use, and also claim to be working on the development of practical prototype thruster. No practical working devices have been publicly demonstrated, and other experiments have failed to corroborate these claims. Yeah, okay, so I guess that's the review. I mean, some theory which violates momentum conservation, inspired by the Mach's principle, and well, an unusual controversy with measuring some small forces which could not be replicated. So what can I say here? Woodward died on August 9th, 2025 at the age of 84. By the way, by 2020 the device was being referred to publicly as the Mach effect gravitational assist, or mega drive. Wired reported that Woodward and Hal Fern secured an NIC funding. I don't know what's NIC. Oh my god. Being in Japan, some disadvantages. No. It's actually NASA. NASA Institute for Advanced Concept, yeah. So the government gives them money. Literally. For the theory which violates momentum conservation. Well, at least now people could not say that, oh, you know, those poor anti-gravity researchers, they're considered fringe and no government gives them money. Apparently they're getting money, so they're doing fine. The same report described device and electric powered propulsion system, while also noting mixed test results, the small scale of the reported forces, and the need for independent replication before the effect could be accepted. Yeah, I don't know. Should I read the paper? Well, okay. Maybe I'll do it later, but for now, let's move on. Woodward. Ning Lee and Dr. AC Gravity. So yeah, I heard about Ning Lee's story before, and actually mentioned her in the previous video. So yeah, UAH scientists who theorized the magnetic field applied to superconductor will align ion spins to produce gravity-electric effect. So yeah, she got $500,000 duty contract, and then she basically was killed in a car accident. Yeah, so what happened to her? Yeah, she got into car accident in 2014 and developed permanent brain damage and died. Yeah. By the way, again, University of Alabama in Huntsville. So I guess maybe they were colleagues. Her husband, seen the accident, suffered a heart attack and died years later. Attempts to gain more insights into her work through Freedom of Information Act requests were reportedly denied. Her work and circumstances prior to her death have resulted in multiple conspiracy theories. She has been included in the missing science conspiracy theory. Yeah, and actually in this case, AI gives us some ideas about her research. I think I have it somewhere here. Yeah, I see Ning and Torr. So it is what's called gravita-magnetic or effect. I don't know, but the thing is, you could look at the Lagrangian. So this is Lagrangian of a system of particles. This is the kinetic term, and this is coupling to electromagnetic field, right, with charges. This is scalar potential, vector potential, and velocity. And that's how they couple it to gravity. Like, that's how they think gravity interacts with matter linearly, just like a vector field. So this is like, which is phi j and aj is gravitational scalar and vector potentials. So in the formalism, gravity works like electromagnetism, which is not how it works in Einstein theory. In Einstein theory, gravity is a two-tensor. It's a metric of space-time. So this is some sort of novel thing. And of course, if you couple it like this linearly, it will produce bigger, stronger effects, right? And they made predictions based on it, on the new theory. So that's what's described in this paper. What the hell they measured, I don't know. Is it true? Is it not true? How do I know? But the theorist behind this study, I think, is clearly this guy. He will appear again later, and also like AI mentions him several times. Yeah, that's one of the papers you reviewed. Another paper like this, another paper like this. So should be similar. And probably I will not read, but you get the idea. Yeah, Douglas, Torr, and Lee. Hmm. Well, okay, something not clear. Let's just continue. Podkletnov Effect. Okay. So, Evgeny Podkletnov. The Russian ceramics engineer known for his claims made in 1990s of designing and demonstrating gravity shielding devices consisting of rotating discs constructed from ceramic superconducting materials. Okay. Yes, so this is his interview. From his interview, someone in the laboratory was smoking a pipe, and the pipe smoke rose in the column above the superconducting disk. So we placed a ball-shaped magnet above the disk attached to a balance. The balance behaved strangely. We substituted non-magnetic material, silicon and steel. The balance was very strange. We found that any object above the disk lost some of its weight, and we found that if we rotated the disk, the effect was increased. Public controversy. Podkletnov's first peer-reviewed paper on the apparent gravity modification effect, published in 1992, attracted little notice. In 1996, he submitted a longer paper in which he claimed to have observed a larger effect, 2% weight reduction as opposed to 0.3% in the 1992 paper, to the Journal of Physics. According to Platt, it's a reporter. A member of the editorial staff, Ian Sample, leaked the submitted paper to Robert Matthews, the science correspondent for the British newspaper, the Sunday Telegraph. On September 1st, 1996, Matthews' story broke, leading with the startling statement: scientists in Finland are about to reveal details of the world's first anti-gravity device. In the ensuing uproar, the director of the laboratory where Podkletnov was working issued a defensive statement that Podkletnov was working entirely on his own. Vuorinen, listed as the paper's co-author, disavowed prior knowledge of the paper and claimed the name was used without consent. Podkletnov himself complained that he had never claimed to block gravity, only to have reduced its effect. Okay. Podkletnov withdrew his second paper after it had been initially accepted. It was accepted. The resulting uproar over the alleged claims in the withdrawn paper was reported to be a primary reason for his expulsion from his lab and the termination of his employment at the university. Well, I don't know what happened. So was it right? And he withdrew because of the pressure, or was it just wrong? Attempted verification. In 1997, the telephone interview with Charles Podkletnov insisted that his gravity shielding work was reproduced by researchers at the University of Toronto and Sheffield, but none have come forward to acknowledge this. The Sheffield work is known to have only been intended as partial replication, aimed at observing any unusual effects which might be present. Since the team involved lacked the necessary facility to construct a large enough disk and the ability to duplicate the means by which the original disk was rotated. Why? I don't know what's the problem. But kind of counters that the researchers in question have kept quiet, lest they be criticized by the mainstream scientific community. Podkletnov is reported to have visited the Sheffield team in 2000 and advised them on the conditions necessary to achieve his effect, conditions that they never achieved. BBC News item. It was alleged that researchers at Boeing were funding a project called GRASP, Gravity Research for Advanced Space Propulsion, which would attempt to construct a gravity shielding device based on rotating superconductors. But subsequent Popular Mechanics news items stated that Boeing has denied funding GRASP with company money. Also, Boeing acknowledged that it could not comment on black projects. It is alleged that GRASP proposal was presented to Boeing and Boeing chose not to fund it. Okay, so Podkletnov supposedly approached by Lockheed Martin, but he refused because he was strongly anti-military. Yeah, I don't know. So in case you didn't get what's happening, so supposedly it's kind of weird. Supposedly, yeah, just the weight of like anything is getting, yeah, any material is getting reduced when it's placed above this rotating superconducting disk. Where is the presentation? Yeah. Yeah, not clear. And yeah, I opened this paper before. So this guy said like he used the same material in even non-superconducting state. And supposedly measured something. So I don't know. But look, like some people had some actual interest, right? So it's not like it went totally unnoticed. Yeah, I don't know what else to say here. Some weird story. Is he still alive? Okay. Let's move on. This is a Torr guy appears again. So yeah, I think he's the theorist behind this whole program. So this is like experimental paper, but they'll refer to him for the theory. So what they were doing here is they were placing masses, like small metallic balls of different materials. You find the picture here, covered with gold, I think, into N2 gas, and they applied the electric fields to it, like this, just from here to here. And then they were measuring the change in weight. And again, I don't know how did they rule out, like ion wind. You see, look at this shape. It's literally, begging for some ion wind effect here. But so yeah, I don't know. I'm kind of skeptical of the results, but they're saying that yeah, the weight is getting reduced. I mean, if you ignore the strange shape and you ignore air wind, when you apply the voltage, right, to a conductor, what happens is that it's getting polarized, right? All the electrons will move towards one side, right, and the positive charges will be stored on the other side. But that's all. There's no net force, right? Why would it be? It's electrically neutral. But they say no, the weight is getting reduced and it's proportional to the mass. So it's like actually gravity effect. Here's the formula. You see? Alpha is some coefficient. And where is the graph? I don't know. No, don't see it. And as a theoretical reference for this idea, they cite, yeah, here is a graph. Weight difference is mass. They cite the work of this guy, Torr. Oh, well, yeah, Vargas and Torr. Cartan-Einstein unification with teleparallelism and discrepant measurements of Newton's constant G. So yeah, here's this paper. I guess let me explain it a little bit. So it is based on unfinished work of Einstein and Cartan, which proposes alternative description of gravity, not in terms of space-time curvature, but in a different form, using a different connection on a different bundle with torsion. Yeah, and torsion is what describes the strength of the gravitational field. Yeah, teleparallelism, it's called teleparallel connection. It was an attempt by Albert Einstein to base a unified theory of electromagnetism and gravity on the mathematical structure of distant parallelism, also referred to as absolute or teleparallelism. In this theory, spacetime is characterized by curvature-free linear connection in conjunction with a metric tensor field, both defined in terms of dynamical tetrad field. So you know what's tetrads? It's basically parallelization of the trivialization of the tangent manifold, tangent bundle. So it's a vector field. In this case, it's 4 vector fields, trivializing the tangent vector bundle. So we define this kind of Wittenbach connection in terms of them, satisfying this property. It has in accordance these coefficients. Yeah, the H are coefficients of the vector field, components of the vector field. So yeah, and I guess the idea is this connection has something to do with gravity equations. So the torsion of this connection is a field strength of the teleparallel gravity. Unlike in general relativity, the gravity is due not to curvature of spacetime, but to the torsion thereof. Yeah, I didn't explain what torsion is, but it's kind of counterintuitive notion. Yeah, I don't know whether Wikipedia explains somewhere. Because in Einstein theory, when a connection only appears, well, connection is something we need in our bundle to compare sections at different points. So for tangent model, it's vectors. It's something needed for parallel transport. And in Einstein theory, connections come from the metric. So metric is fundamental, and it induces what's called David-Schwitter connection. It's somewhat canonical, and it's famously torsion free. The torsion is some sort of symmetry of this connection. I don't know. It's the torsion measures the difference between parallel transport of one vector field along another versus the other way around. Yeah, but it's hard to give it like intuitive meaning. And yeah, in Einstein theory it was 0, but here the theory is based on it. Yeah, torsion tensor. Yeah, so in different geometry, the torsion tensor is a tensor that is associated to any affine connection. The torsion tensor is a bilinear map of two input vectors x and y that produces an output vector t of xy, representing the displacement within tangent space when the tangent space is developed or rolled along the infinitesimal parallelogram whose sides are x and y. Okay. Well, hard to imagine. Yeah, it's well, I wish there were a picture here more clear than this. No, okay. So anyway, this guy so he refers to some written communication between Einstein and Cartan to some letters. Yeah, so you see this equation appeared on page 47 of the published Cartan-Einstein correspondence on teleparallelism, contain the following equation for the torsion. So you see a set of equations, and he says, look, he puts some of them components equal to 0. For the other ones, we are getting Maxwell's equations. Yeah, and actually, so the reason why Einstein failed. Yeah. So yeah, his attempt failed because there was no Schwarzschild solution in his simplified field equation. So that's the problem, right? He was not able to reproduce observable reality. Yeah, and if you want, there is the Cartan and Einstein letters that translated. We could read them. You could read it for yourself if you're curious about it. Where is the first letter? Oh, there's many of them. Let's just say, Monsieur, illustré maitre, who knows French? I don't know French. Je m'excuse de prendre des caisse instead de votre temps. Well, okay, so it's French and it's translated. Monsieur illustré maitre, I apologize for taking a few months of your time, which is so precious for science. I decided to write to you on my friend Langevin's advice. New recent articles, Sitzungsberichte devoted to new theory of generalized relativity introduce the notion of Fernparallelismus in the Riemann space. Yeah, he's saying it's basically a special case of a more general notion of a space with Euclidean connection, which I outlined briefly in 1922 in the article The Comtesse Reduce. I even remember trying at Mr. Hadamar's home to give you the simplest example of Riemann space with Fernparallelismus by regarding two vectors within the sphere making the same angle with the meridian lines passing through their origins as parallels. The corresponding geodesics are the rhomb lines. Okay, so that's his letter. He explains something here to Einstein, and then yeah, Einstein replies in German. Lieber Herr Kalik, ich sehe in der Tat ein, dass die von mir benutzten Mannigfaltigkeiten in den von Ihnen studierten als Spezialfall enthalten sind. Auch die Herren Eisenhardt, Princeton und Wetzenbock sagen haben die mathematische Grundlage meiner Neotheorie bereits teilweise von mir dargelegt. I don't know how to read this. Okay, so there is a translation. Dear colleague, I see indeed that the manifolds used by me are a special case of those studied by you. Eisenhardt and Princeton and Weizenbock also partially laid out the mathematical foundations of my new theory before I did. The latter, in an article published in our academy, has given supposedly complete bibliography of relevant mathematical works. But he has quite overlooked your work. Oops. But I'm a bit puzzled as to how I should do it so as to satisfy all just claims. Okay. Yeah. Look, I didn't at all understand the explanations you gave me in Paris. Still wasn't clear to me how they might be made useful for physical theory. I first remarked last year that it would be quite natural to add the hypothesis of distant parallelism to the Riemann metric, but only in the last few months have I realized that this actually leads to a theory which corresponds to hitherto existing knowledge of the physical properties of space, yet to a useful set of field equations almost uniquely determined by formal considerations. I'm sending you to my articles on the subject, asking you to forgive my inadvertent plagiarism and to help me settle the matter satisfactory to everyone's benefit. With best wishes, I am yours, Albert Einstein. So yeah, again, I don't know how much you should read this. It's kind of curious, of course, to see, you know, those people at work. Cartan is, well, very famous. I mean, he's kind of one of the founding fathers of the, you know, modern differential geometry, so to say. So yeah, so they're trying to work on a paper together. Yeah, there's some equations up here with this constant c. We'll see it in Torr's work as well. It's kind of different formalism, as I was trying to say. So he claimed that he was able to resolve Einstein problems by switching from a Riemannian geometry to Finster geometry, which is like nonlinear generalization of Riemannian geometry. Yeah. Around that year, it was a self-evident truth for Einstein, not needing further justification, that the ultimate geometric theory of the physics must involve teleparallelism. This is reflected in a single statement with which Einstein both dismissed Riemannian geometry and introduced teleparallelism. Referring to Riemannian structures, he said, given points A and B, separated by finite distances, the lengths of two linear elements placed on A and B can be compared, but one could not do the same with their directions. But why in Riemannian geometry there is no parallelism at a distance? Yeah, this part I don't understand. Okay, this is the same field equations now with a source to mimic, you know, electromagnetic field, and then he tries to find a solution in this constant c, where c is some constant factor. C in the system equations specifies the relation between the electromagnetic field and the torsion only up to a constant factor, which will begin later in the paper. Okay, and then he claims that he was able to find the solution. We scroll down. Well, of course, I haven't checked any of this. Where is the solution? He said he was able to find this constant c. This is interesting. How is it even possible? Yeah, and now finally he presents the Schwarzschild-like solution here. Here it is. There is some metric of a Schwarzschild type, yeah. So spherically symmetric body. And the final answer is that, yeah, as you can see, we have a standard Schwarzschild term and this correction. This is the Q is the charge of the planet. Okay, so the planet has to be charged, and this is the standard. How do you call it? Charged black hole metric term, right? Yeah, Reissner-Nordstrom. Here it is. And this is the correction. This is the new correction, which changes the Newton potential effectively. And his claim is that, well, it could be noticeable if the plane has some charge, which I just don't know why it should have. Isn't kind of zero in total. So it could be noticeable, and his hypothesis that that's what affecting the measurement of gravitational constant, which I already kind of mentioned in the previous video, is is problematic. So partially because it's very small. As you can see, the measurements, different measurements literally don't agree with each other. Even they have non-overlapping uncertainty intervals. This is the measurements of gravitational constant, and this is actually a news article because recently people tried to measure it again on May 6, 2026. Newton's gravitational constant G is still known to just 3 significant figures in 2026. New measurements merely highlight our uncertainty. And they failed. So, I mean, the discrepancy still persists. So this person's claim is that maybe it's not a coincidence. Maybe it's just not really how it works. Maybe the electromagnetic fields affect the measurements strongly than we initially thought. So that's his theory. I don't know, it's kind of a bit weird still, like that's just proportional to the total charge of the planet. Yeah, I don't know. I don't know what to say about that. Yeah, one reason why there could be discrepancies is because the constant is the gravity is really weak, so it's hard to measure. But that's usually not the case with other small quantities which we measure. So yeah, that's a mystery. Yeah, I don't know how to resolve it. Okay. this. Okay. So it's his colleagues or something. Oh, more reverse engineering Podkletnov experiments. Okay. Experiments supported by Podkletnov suggest that gravity modification is within reach in our lifetimes. Solomon used process models to introduce the concept of not inertia knee fields and derived the mass gravitational acceleration formula that is consistent with Hooft's finding that absence of matter no longer guarantees local flatness. Yeah, I don't know. The observed weight loss with the station disk is due to the asymmetric magnetic field, and the observed weight loss with the spinning disk is due to the magnetic knee field. What is this knee field? No. Yeah, I don't know. I haven't read this paper. Claude Poher. Google patent. So what? He has a theoretical paper. Can you read it? Oi. We observe propelling accelerations of half-kilogram size matter mass during low-energy electric discharges into a patented space electric thruster named emitter. The device is made of graphite-based partially superconducting material, what does it mean, at laboratory temperature and metallic conductors. The emitter propels from theoretically predicted interaction and emission of gravitational quanta, bearing momentum so without ejecting matter particles in space. Mm. Method. Wait. So this is experimental paper. Yeah, so that's a theoretical paper. We propose a quantum model of inertia using two main hypotheses. Existence of a general isotropic flux of quanta, named universons, which differ from gravitons, propagating at light velocity into the universe. A very short time duration, interaction of this quanta with elementary massive matter particles with temporary momentum transfer. Model parameters values are obtained from observations. Natural fluxes are random fluctuations in intensity and interaction predicted to be the cause of gravitational acceleration. A model of gravitation is deduced. Predictions of the two models are confirmed by free fall of cold neutrons and by strong electron accelerations into superconducting devices. Supplementary cosmological acceleration H0c from universe expansion is predicted and confirmed by astronomical observations. Galaxy rotation velocities are predicted from quantum fluctuations and HOC effects. So in the enigma that required cold dark matter mass hypothesis. Okay. We propose a quantum model of inertia using quanta named universons to distinguish them from hypothetic gravitons. The motivation present work are gained from astronomical observations of galaxy rotation curves. Okay. The motivation, okay. This push from the quanta would be present everywhere. So, okay, so he's saying that like gravity is caused by some particles pushing things together or something like this. The idea of gravitation could be the result of a bombardment of subatomic entities is not a new one. Searl authors have proposed since long models when an isotropic flux of fast-moving quanta travel in the universe, interact with matter. But I don't understand how it works exactly. Why is it this thing pushes masses towards each other? They're pushing the two masses of matter one towards the other. Yeah, two hypotheses required for the model. A huge isotropic flux of gravitational quanta propagating light velocity into the whole universe. These quanta carry each the same positive tiny kinetic energy, EU. There is an interaction of this quanta with all massive elementary particles of matter they cross. This interaction has two properties. Firstly, it's temporary, with a very short duration t, during which the positive quantum momentum is transferred to the matter particle. Moreover, there is not any absorption of the quantum energy after the interaction is finished. Okay. Well, okay, so it's some theory where gravity is caused by quantum pushing of particles, of some well, of some hypothetical particles on all the bodies. Yeah, I don't know whether should I read this. Tested at NASA. Morning stars. Well, this we already saw. It's the same as Searl machine. Boeing Phantom works. We already read about it. In the Podkletnov Wikipedia page. Recent declassification. And what was there? But that's when they revealed TikTok videos. While the documents have significantly changed the conversational piece, they have not produced conclusive public evidence for extraterrestrial technology, which in many cases remain unresolved. Okay. So anyway, the future, what's the next step? What now? We need theories with testable hypotheses. Independently funded research by private interest is required. Promising results always disappear into the classified realm. How do we fix this? Thank you. Amy Eskridge. Yeah, okay. I hope I give you some review, but yeah, there's just too much stuff. There's many papers which you cannot read myself. It's just too long. I don't know how much time I should spend on it. Should I read Einstein Letters? Should I read Torr's gravity paper, or this Universons, or maybe this where's this Woodward guy? And I lost him already. So I don't know. So what do you think about it? I think it would be great if government funding sites would disappear, and then the free market would siphon all this. Well, would actually would be able to filter really promising theories from non-promising ones. Like only the market could do this calculation. I don't have time to do it all myself, right? It's just impossible. So yeah, unfortunately we are kind of stuck with what we have, which is like overbloated mainstream, which sucked up all the talent, and also some kind of little developments, borderline some fringe science, right? Or no, without proper experimental testing. So that's, I guess, the end of this review. Kind of sad that Amy Eskridge has died. I would like to know the truth about what happened, but probably we will never know.